We can also perform certain operations on strings, all of which seem very similar to things that we've done before. However, there's a little bit of a caution because we have to remember that the computer is incredibly literal, and some of these things are slightly counterintuitive, and we'll work some examples to demonstrate those things in a moment. The first operation we can perform with strings is that we can concatenate them using the plus sign or the plus equal sign. Just like with lists, if we wanted to create a list of a few values repeated many, many times, we can do a similar thing for strings when we have a lot of repetition that we would like to use to build a string, and we'll see an example of that in a moment. We can compare strings for equality and inequality, and we can use each of our positional operators of less than or equal, greater than, and greater than or equal with strings as well. But particularly here is where we're going to find some counterintuitive results. So let's go to REPL and experiment with each of these operations. First, let's see an example of concatenating strings. If I create a string variable called name and set it equal to Alexander, and then I'd like to add to the value of name a last name like Hamilton, I can ask Python to print name, and it will give me Alexander followed by Hamilton. Just note that the computer is very literal, and so there's no space there because I didn't tell it to add a space. So simply using the plus or the plus equal will not put a space there the way you might think it would. So if you did want to space out your first name from your last name, you would want to do something like adding a space right here in order to visually see that space and have it be part of your name string. Next, let's do an example where we might want to use that multiplication operator. Let's create a variable called shining, which holds the value, all work and no play makes Jack a dull boy. If I add a multiplication times a numeric value to the end of that, and then ask Python to print this string, what we'll find is that we don't have just what was written there one time, but in fact what was written there 20 times. And so we can use this multiplication to duplicate what's within the single or double brackets this number of times. Third, let's take a look at some examples of comparing strings for equality and inequality. Because a capital letter and a lowercase letter are distinguishable in the English language, and because one of them is performed on the keyboard while holding the Shift key or having your caps lock key down, your computer will recognize words with different capitalizations as truly different. We can explore this by creating a branching statement and asking Python if the word zoo with an uppercase Z is equal to the word zoo with a lowercase z. If it is, we'll print yes, they're equal. Otherwise, we'll print something else. And now when we run our code, our program prints alas, because it thinks of these two words as being different because of that one change in capitalization. And the same would be true for punctuation, for spaces, and other things of that nature. Another thing we need to be wary of when checking strings for equality is when we use numerical strings. We can ask Python if the string 1 is equal to the number 1 to print one thing, and if those two things are not equal, to print something else. Predict what you think will happen, and notice that we do not think of the string 1 as being equal to the number 1. And it doesn't matter if you have an integer value over here or a floating point value, we get the same output. And although we can see the quotation marks and simply ignore them to see what's on the inside, Python is not capable of doing that. And if you want to check a string that you know happens to be a numerical value to a numerical value, what you're going to need to do is cast the string as an integer before you make that comparison, and that's enough to change your outcome. Yet another cautionary tale comes when we look at comparing strings with a less than sign. Now there are different ways we might think of strings as being compared for one being less than the other. We may compare them by length, for example, or we may think that we ought to compare them alphabetically. If I run the bit of code that I have right here, Python actually believes that the word zoo comes before the word ape. Now that's very shocking, but notice that the Z that I have in zoo is a capital Z. When Python compares strings using less than or equal to, greater than or equal to, it's using what's called the Ascii character code, which takes every single key that you could enter on your keyboard and associates it with a number. Then Python iterates through the indices of a string, and at the first time that the corresponding integer value at a particular location is less than the corresponding integer at the same location in the other word, then that is how Python deems that one word is less than the other. So it's not at all what you would think in terms of alphabetical order or the length of the word. The reason that this example is failing is that the Ascii character code gives smaller numerical values to capital letters than it does to lowercase letters. So anything that begins with a capital letter here would come before a word that begins with a lowercase letter. If I change the capital Z to a lowercase z, then the Ascii character code does what you would think, and the value that it assigns to little a is going to be smaller than the value it assigns to little b, and so on and so forth. So if you have the same capitalization schemes between two words and you're comparing them for less than, then your computer will behave alphabetically. What you need to be careful of is if you have strings that contain numerical values or non-numeric keys or capital letters intermixed with lowercase letters, then weird things can start happening when comparing words with a less than sign, and so it's something you just need to be aware of.